Rina Haseki from Yamaguchi University in Japan. So as he mentioned, I'm doing my research with collaborate with Dr. Lei Hou in MIT University as a visiting scholar. So today I'm presenting my research instead of Dr. Lei Hou. Okay, let's start. Wait. Yes. Okay, so I'm from Japan, and Japan has a lot of places, and more than 700,000. So in such of those places, and my research focuses on places, especially steel or metal. And the left figure shows the number of places of construction ages in Japan. As shown in this figure, it is really aging because almost over 50% of all of them is already takes 40 years old. So in the right side, when we change taking the materials of superstructures, the steel is almost 38% of all of them. And when we think about the deterioration of the steel bridges, the fatigue or corrosion is measured. And in this deterioration, I focused on corrosions. And in order to reduce such corrosion deteriorations, we can find the two big problems. So for example, to prevent and maintenance. About the preventions, removing the border oxidants from steel surface or painting steel surface and using high corrosion resistance materials. And also for maintenance, the detecting and monitoring H2O or O2 because it is caused for the corrosions and classifying corrosion level, also repairing or looks like that. So the red box are my research focusing areas. So more details, using high corrosion resistance materials, I am trying to combine stainless steel and mild steel. Looks like these figures. And also, I try to develop simple maintenance of monitoring methods by making classifier based on images. So far, I conducted on the CNN, making CNN, and now I'm trying to use hyperspectral. So today I'd like to talk this one. So as I said, my research goal is proposing simple monitoring methods for steel bridges. And in today's presentation, my objective is to confirm the ability of hyperspectral camera for steel bridges by to clarify the requirements to obtain the hyperspectrum, and also to clarify the relationship between hyperspectrum and corrosion level by comparing hyperspectral with mass thickness and elements on the surface. It looks like that. So it is really initial stage, so just a fundamental research. So this figure shows the hyperspectral camera's details. So we use this camera, and this camera can take the hyperspectral from 380 nanometer to 1000 nanometers. And the specific function of this camera is it can obtain the near infrared spectrum. And for taking pictures, we need to reference picture. It takes almost 2 minutes. After that, we can take one picture by 1 minute. So it's not to take too much time, I think. And the below figure shows the fluorescence light and halogen lights, the relative values. So as shown in these figures, if we try to get near infrared, we need to use halogen light because in the fluorescent light don't have enough light for such a high wavelengths. So those pictures show the situations when we try to take pictures in our lab. So use halogen light and hyperspectral camera set as the light side. So it keeps distance of 0.2 meters and by the horizontally. So as an initial study, we try to obtain the hyperspectral of water in Petri dish because I mentioned the water is really main effects of corrosion. So we try to detect that. So I've shown those figures, the with the halogen light and without halogen light, it's really bit different. And if we see here without halogen light and the sunlight, the the spectrum is not a constant, so it's really bit dark. So from this result, we try to use halogen light to take such a spectrum. And to clarify the relationship hyperspectrum and corrosion levels, we prepared some specimens. And as I mentioned, I try to use the stainless and mild steel to combine. So in this study, I use such the combined materials, the combined specimens. So first, we conducted the corrosion test for the welded specimens and obtained hyperspectrum and surface appearance pictures and last thickness and elements distribution as well. So more detail, they are showing the left figure, take pictures and take the last thickness, and also get hyperspectrum as shown in the top of the middle. And we use the Python to make the such a hyperspectral imaging of each bond. And also we did the elemental analysis to get the some elemental mappings. So this figure shows the test cycles for corrosions. Just I mentioned, the 8 hours is one cycle of our test. So I hope it can move. Yeah, it's okay. Now this animation shows the result of cell cycles, 3 cycles, 6, 9, 12, and 15 cycles of result. It's really difficult to see, I guess, but when we check the surface appearance, it becomes more and more clouded. And the left side is the SM, it's mild steel, and the right side is stainless. So, and when we check each mapping, I will show you later. Especially in 104 band and 1901, it's near infrared, is more big changes. So we think we can get any information from such a band. So, okay, let's see each cycles. So at first, it's no corrosions. All of band is not big, let's say big difference in distributions. All of them looks same. And when it's a little bit corroded, it has big changes on 104 and 190 band. And for 104 band, it should come from the appearance images because the corrosion last has a red light, so that's why it's changing. And when I see the 190 band, it's also changing. And we try to check what is the reasons why. So in this time, we check the NN and CL because we put the NSCL in the cyclic test. So it's really difficult to see that, but somewhere can same distribution of CL and 190 band. And when it's continuing the corrosion test, it also have same distributions. However, it is not now. We don't know it is based on NSCL or any other elements or more any other reasons for affect such bond. And here is 9 cycle and 12 and 15 as well. Yeah, as shown in these figures, that for 15 cycle, it will be more corroded, but the distributions of the each bond is not becoming directly big. It sometimes go down and go big. So we need to check what is the reasons of them. Okay, my presentation is really short. It is the last slide. The conclusion. Hyperspectral camera has the ability for obtaining some additional information from corroded steel surface. In additional means I try to do my research only the pictures, but it's a little bit difficult to take the leveling. So I try to more additional information by images. And also the halogen light is required to obtain hyperspectral of near infrared. And now as the future works, how to control the light on actual bridges. So in this next 2 months or 3 months, we try to do that on actual bridges. And at start, the hyperspectral images distribution of reflection intensity of near infrared band have been changing with corrosion progress. So now we are trying to find out what is the main reason for the change. And it's at the end, reflection intensity of near infrared band may show the corrosion level, the progress or stages. Okay, this is the end of my presentation. Thank you for your kind attention.
Thank you so much. Great presentation and great timekeeping. Thank you. You've recovered our Friday evening for us. Questions from anyone? Yeah, John Chun.
Thank you for very interesting presentation. Although I probably don't understand most of them, but I'm very interested on your hyperspectral camera, how small it can be, because I saw you have big equipment. Can we make it smaller?
Yeah.
The equipment itself? Oh yeah, that size. So actually, right. But you need a special lights, right? And to be able to explore the corrosion. Just surface one, or you can penetrate through.
No, it is really important point. It's just only surface.
Okay.
Yeah.
Okay. It's, I think we have a department, not yesterday you saw Professor DK Liu has a group doing those robotic, and we can fit this one in, so they don't, they should go around.
Yeah.
If you can go a little bit deeper, and that is going to be, Harbour Bridge has major problem is the corrosion. Each time when they start to painting from this end, and then means they just finish that end. So they go around, yeah, each time to finish one, they have to start again. But that's why the robots become very popular for them. But this is amazing anyway, because they can do inspection. But thank you.
Thank you. Any further questions? Oh, yeah. Yeah, thank you.
Thank you very much. Great presentation. And as Genshin just mentioned, there's a lot of application, practical application of this technology, not only on bridges, but in mine sites and process heavy industries. You know, just corrosion is a major issue. So it's not my question, just a comment. I think Data 61 did a bit of work in the past around this as well. So I think probably it's worth getting in touch with them to understand what the learnings are. But yeah, this is a really interesting project, and it's got an immediate practical application.
Thank you.
Thanks, Govinda. Anyone else? I will, if nobody else will. I'm kind of interested in the basic hypothesis. Like, who kind of thought, or what was the thinking behind, hey, let's buy one of these cameras and, you know, let's just see if it shows us corrosion. I mean, like, what was the thinking? It's great if it, you know, there must have been a hypothesis behind it. Like somebody must have thought, maybe this camera can show something for a reason, right?
Sorry, I didn't understand.
I should have spoken better. What was the origin of the idea to try this camera to find corrosion?
Okay, thank you so much. This hyperspectral camera is so far used for the detect the trees of the glows of the glows of the trees or anything else. But as I mentioned, so far I tried to leveling the corrosion levels by only normal pictures, but I feel it's really difficult to get robust for another bleaches. So I try to get more information, and this hyperspectral more far infrared can obtain more information such as elemental, for example, chloride or any other things. So if I can get such a portable one to take pictures and get any information of the another information, so it may helpful to leveling of the classifying of the corrosion levels.
You make it sound simple, but that's a really fantastic. That's a fantastic progression of discovery. Well done. Well done indeed. Anyone else have any question or? Okay, we'll close this